Unit 7, Biomechanics in Sports and Exercise Science. 7.1, Investigating Linear Motion in Sport and Exercise Science, Task 1. Felix Walker. Okay, so what is biomechanics? Biomechanics is the mechanics of living beings and studies of human movement and the movement of objects that humans repel when they play sport. This definition was proposed by Stafford Brown, Rea, and Eldridge in 2016. And basically it suggests that sports can be explained by different forms of motion. And it can be broken down into bio and mechanics. So bio looks at functional anatomy and muscular tissue, and mechanics looks at kinetics and kinematics. Types of motion. So there are 3 categories of motion: general, angular, and linear, which are used to explain the different movements of both sports, athletes, and equipment. Linear motion refers to motion which is also known as true motion, and can be divided into rectilinear and curvilinear. Rectilinear motion suggests an element of straight line motion, where all components of a system act in the same way, like distance, direction, and speed. For an example, an athlete competing in a 100-meter dash along a straight track would be rectilinear motion due to the movement being straight line. Another example could be the gravitational forces acting on a ball when it free falls. Curvilinear refers to the motion being on a curved line. However, this is not rotation. For example, the motion of a bobsled team or running a 200-meter dash would be curvilinear. This is because the motion is in one direction, but the path taken is not directly straight, like the bobsled and athletics tracks and how they curve. Angular motion, also defined as rotation, suggests movement is performed around an axis. So, for example, swinging a golf club or a baseball bat when striking the ball. General motion is referred to as a combination of both angular and linear motion, and is the most common in sporting situations. For example, a footballer running with a football is general motion, as there's both rotation of the ball and linear motion of the footballer running. Mass. So mass is the measurement of how much matter there is in an object, or is defined as the quantity of matter of a body that a body possesses, human or object, and that's Adams et al. 2016. Everything has a mass, but masses can be different depending on the density and volume of an object. The formula for mass is volume times density, and can be used to calculate an object's mass in kilograms. For example, the average mass of a human being is 62 kilograms, and the average volume of a human is 62 cubic centimeters. Therefore, the density of an average human is 1 gram per unit volume in milliliters. Weight is the force exerted on the mass of a body by the gravitational pull of the Earth, which is roughly 9.8 meters per second squared. Weight is calculated in newtons, and there are many sporting examples where weight can have a positive or negative effect on performance depending on the sporting situation. For example, 2 athletes who are competing in a marathon generate the same amount of force but have different weights of 75 kilograms and 90 kilograms. When running long distances, it's desirable to not carry excess weight. Therefore, you'd expect the lighter 75 kilogram athlete to finish before the 90 kilogram athlete. Another example where a heavier weight is more desirable could be during a boxing match, as the athlete would have more weight behind their punches, making them more deadly compared to a lighter athlete. That is if the boxer had the exact same level of skill and ability though. Vectors. Vectors are values which have both magnitude and direction. Magnitude refers to size and direction refers to which course a body or object moves. For example, there are positive and negative direction. Weight is a vector as it requires both gravitational pull, which is a direction, and mass, which is a magnitude. Scalars. Scalars are values which only have magnitude. Magnitude refers to size. For example, how big, fast, or far something is. Mass is a scalar quantity as it only requires magnitudes like volume and density to be calculated and explained. Distance. Distance is the sum of all movements regardless of direction and is the length of space between 2 points an object or a person travels. It is also a scalar quantity, and an example would be the average speed travelled in a marathon is 26.2 miles, or a rugby player might use a specialist type of equipment to calculate how far they have travelled in a game, tracking their path in the process. Displacement. Displacement is the change in position of a body or object during a time interval and is the straight line distance from start A to the final point B in a particular direction. It is different to distance as it doesn't take the route of the object or person. It simply goes from the first point where it started to the point where it finishes. For example, when throwing a shot put or javelin in a competitive situation, officials measure how far an athlete has thrown the object from where they are standing to where the shot put or javelin lands. The distance achieved by the athlete is therefore displacement, not distance. Speed. So, speed is calculated by distance divided by time. This gives us an average speed, meaning how fast an object or person has moved from start point to finish point. For example, Mo Farah's PB time for the 5,000 meters is 12 minutes and 53 seconds. To calculate the average speed of his run, we need to change his time to from minutes to seconds, which is done by timesing his 12 minutes by 60, referring to how many seconds are in a minute, and then adding the extra 53 seconds, and that gives us 773 seconds to do his 5,000 meters. Now we can divide his distance, the 5,000 meters, by his time taken to give us his average speed, which came out as 6.46 meters per second. However, his pace would not have been the same throughout the race due to tactics like a strong start or a sprint finish. Therefore, his speed for different sections of the run would have varied compared to 6.46 meters per second. This is just a quick example of distance time graphs. The green line shows a fast speed, which is also steady, moving from 0 to 100 meters in 5 seconds. The blue line shows a journey with a stop of 2 seconds and then a return to the starting position. And the red line shows a journey starting at 2 seconds later than the other two, with an initial acceleration, then a deceleration, followed by a stop. Velocity. So velocity measures the rate at which an object or person has been displaced or experienced a change in position. Other definitions say that velocity is the speed of a body or object in a given direction. Velocity is a vector as it has both magnitude and direction. For example, in speed skating, having good velocity can be the difference between winning a race and finishing last. Skaters need to generate large forces to increase their velocity and overcome air and ice friction. Another example would be swimming. Swimmers need to generate strong velocity to move more efficiently through the water. This is just a quick example of a velocity time graph. The object or body started by accelerating slowly into a faster acceleration, then reaching a steady speed, followed by a rapid deceleration as they slow down and come to a stop. The object or body then speeds up in the opposite direction until reaching a steady speed. This graph could be representing, for example, a runner who is running a circuit where they turn around halfway through, where their velocity changes during the run. Acceleration. Acceleration is the rate at which the velocity of an object or body increases over a certain period of time. Acceleration is a vector quantity, meaning it has both magnitude and direction to be explained and calculated. To work out acceleration, you take away the starting velocity from the final velocity, then divide it by the change in time. For example, a winger in rugby needs the ability to accelerate at high speeds to prevent being tackled. If their velocity is high and their change in time in a set period is low, then they will be accelerating successfully. This example could also be applied to sprinters of almost any sport, who need the ability to travel in a certain time to gain competitive advantage, like wingers in football or Olympic sprinters over short distances. Deceleration. Deceleration is the rate at which the velocity of an object or body decreases over a certain time period. So it's the exact same concept as acceleration, but the opposite action. So one's going up, one's going down, this one's going down. For example, in a sport like netball, players need the ability to decelerate rapidly when catching the ball. This will prevent them from fouling by doing footwork, where you move with the ball, which isn't allowed. This will result in the opposite team being awarded possession. Deceleration is also key in football, as players need the ability to change directions in set periods of time. Players who play attacking roles are more likely to have better agility, acceleration, and deceleration. Momentum. So momentum is the abundance of motion of a moving object or body and considers both mass and velocity as key factors. And it is calculated using mass times velocity. Momentum is a vector, meaning it needs both a magnitude, which would be mass in this example, and direction, which would be velocity, to be explained and calculated. For example, different objects have different momentum. A bowling ball is roughly 6 kilograms and bowled at roughly 16 miles per hour, which is roughly 7.2 meters per second. Therefore, the momentum of the bowling ball would be 43.2 kilograms per meters per second. An example of where momentum is hugely beneficial would be the use of momentum in rugby. A rugby player will attempt to generate the most momentum as possible while running with the ball. For a rugby player, the higher the mass and velocity is key to making it harder to be tackled as you create more momentum. Inertia. Inertia is a property of matter which displays resistance to any motion unless overcome by an external force. Essentially, it concentrates on an object or person's mass. It is harder to change someone's inertial value unless you change the mass of the object or person. Inertia is a scalar, as you only have a magnitude, which is mass, to explain the concept. Athletes have different levels of inertia depending on the sporting situation. For example, a sprinter like Usain Bolt will have a very low inertial value as he is able to sprint at high speeds with less resistance. Although sprinters usually have a higher muscle mass, they train to overcome the resistance and use the explosive muscle fibers they possess to accelerate at high speeds. On the other hand, it is beneficial to have a high inertial value. Rugby players who play in the scrum need to be able to withstand the momentum of opposition, and having a very high mass makes it harder for the opposition to move them.